All right, making dilutions notes. Okay, we already know the difference between concentrated and dilute. Okay, concentrated is when there is a large amount of solute and a small amount of solvent, versus dilute where there's a small amount of solute and a large amount of solvent. Okay, so making a solution less concentrated by adding more solvent is how we're going to dilute something. All right, and the solvent we usually use is water. Okay, why would we need to do a dilution? Because acids are usually acquired in a concentrated form. These acids are diluted to a lower concentration by adding water. So when y'all use like hydrochloric acid in one of our labs, I dilute it down before you use it because we don't want to use something really strong. Okay, so we're going to solve equations by using this formula, which says the initial molarity or concentration times the initial volume equals the final molarity or concentration times the final volume. All right, safety note, always add acid to water, ANW. All right, let's look at some actual problems. We've got dilution problems number 1. I've got your formula here, your definitions here. So remember that we are adding water to a concentrated acid and diluting it down. So this means your larger molarity is always M1. So make sure you read these carefully. How much concentrated 18 molar sulfuric acid is needed to prepare 250 mils of a 6 molar? All right, so M1, initial concentration, I'm going to add water and dilute it down to my final concentration. So M1, M2. So I'm going to write my formula, M1 V1 equals M2 V2. Okay, so 18 molar sulfuric acid, dilute it down to 6 molar. All right, now let's look at our volumes. How much concentrated? So I'm looking for a volume, but I only know this other volume. I have 250 mils of a what? Of a 6 molar. So if this is the 6 molar, I have 250 mils of it, so that makes that V2. Put mils out there. 250 mils, right? So what I don't know is V1. All right, so I'm going to solve by dividing both sides by 18 molar, right? That'll cancel out. So V1's going to equal, hit control divide, 6 times 250 on the top, 18 on the bottom, control enter, and I get 83.33 what? Well, those molarities cancel out, milliliters. So this says I need 83.33 milliliters of the 18 molar sulfuric acid to prepare 250 mils of the 6 molar. So you're going to do this same thing on 2 through 5. Make sure you're reading, because like right here it says I have 100 mils of a 2 molar. I don't have 100 mils of the 12 molar. So that makes a difference when you're assigning these variables. Okay, let's look at dilution problems number 2. Because this is the same thing. We're still using our same formula. We've got M1 V1 equals M2 V2. Right, so let's look at this one. If 225 mils of a 1.25 molar sodium hydroxide solution, so here's a base we're diluting, is used to make 350 mils aqueous solution, what is the molarity of the dilute solution? So here, if I'm looking for the molarity of the dilute solution, I'm looking for M2, right? And it says I have 225 mils of the 1.25. So that makes that V1 M1. 1.25 times 225. Okay, and then I have 350 mils here because that is going to be my V2. All right, so I'm going to solve it the same way. I'm dividing both sides by 350. Right, this will cancel out. And then, so this is what I put in the calculator. And I'm solving for M2, so I'm going to end up with a molarity, right? So I'm going to have that with an M because my milliliters will cancel out. And again, you don't have to change milliliters to liters on these to solve. So what I have, I've got 1.25 times 225 divided by 350. And here we've got 0.8 molar. That's how you would say that. Solution. Can you see that? 0.8 molar solution. All right. I want you to solve all the rest of these using that formula. Let me know if you have any questions.